7b. Types of forces. Recall the 4 types of forces that we in Physics 11 will focus on. They are gravity, friction, normal, and applied. The force of gravity, Fg, Fw, or lowercase w, is a pull exerted on a mass by another mass. The larger the mass or masses, the greater the pull. Weight is the resultant force created when a gravitational field pulls on a mass. Mass m is the amount of matter in an object, measured in kg, kilograms, while weight is the effect of gravity on the mass, measured in newtons, n. The formula for mass, or gravity, or weight, is mass times gravity, Fg equals mg. For this free-falling mass, the only force acting on it is gravity. The force of gravity is a vector, so it may be represented by this downward-facing arrow. For the mass on a table, Fg is still straight down, as is this mass resting on an incline. And for this freely hanging mass, the force of gravity is still straight down. Normal force, Fn. This is a force that acts on a body that is resting on a surface like a table. This force is perpendicular to the surface that it's resting on, and can be described as a pressing force created by an object pressing against a surface. In this example of a free-falling mass, there is no normal force. There is no surface that the mass rests upon that supplies a force that supports the mass from falling. For a mass resting on a horizontal table, the normal force is perpendicular to the table, which makes the normal force straight up. For this mass resting on an incline, the support or normal force is again there and is still perpendicular to the surface it rests on, which makes the normal force point off at an angle, while Fg is still straight downwards. Note how normal force is not necessarily a vector that is purely opposite to the force of gravity. Tension force, Ft, is a force that is transmitted through a rope, string, cable, wire, or the like that is pulled tight. The tension can be a result of gravity, an applied force, or friction. The force is parallel to the wire and pulls equally on both ends of the wire. If an object is freely hanging, then the tension force is similar to a normal force, where it is in the opposite direction to gravity, but is found along the entire length of the rope in both directions. We can see this in this illustration. Gravity is pulling down, and tension is up at the end, attached to the mass, but tension is uniform along the entire length of the rope. In this example of 2 masses suspended on a pulley, gravity is acting on both ends, which results in tension along the rope that is equal at both ends of the rope. For a falling mass, there is no force tension. For a mass on a table, there is no force tension. For a inclined mass, there is no force tension. However, a suspended mass does have force tension. In this case, gravity would create a force straight down. Tension force would be along the wire, pulling straight up, but equal in pulling in all directions along the length of the rope. Force applied, Fapp, is any force that acts on an object in an effort to move it. It does not necessarily need to succeed, though. This example shows a girl and a boy working together to try to move a wagon. If the gray mass is the wagon, the force applied by the girl can be represented by this red arrow, while the boy can be represented by this black arrow. In Physics 11, we'll be working with problems involving inclines. That means that forces applied will not be purely horizontal or vertical, but may be at an angle. And as a result, you may need to find components using trigonometry. So the force applied will have an x and y component values. As a result of the incline, forces such as normal force or friction force may be increased or decreased. For example, this fellow moving these boxes up an incline. If this gray mass represents the boxes, then the black arrow represents the force applied, while the red represents the y component and the blue represents the x component of the applied force. Friction force, Ff, is a force that opposes motion. It's created when 2 objects come into contact. Friction force is affected by normal force. As normal force increases, so does friction force. If friction force is large enough, it will keep an object from moving, or make it so that a large applied force is necessary to make it move. It is always represented by a vector that is parallel to the surface and is perpendicular to the normal force. If this gray mass represents an object moving on a horizontal surface, then the force of gravity would pull straight down. Since the box does not fall through the tabletop, then there must be a support force, which we call the normal force. Now, if we push or pull the box to the right with an applied force, then the object may or may not move to the right. The force that resists the box motion, called the friction force, will be directed to the left. The friction force is related to the normal force, essentially the object's weight. The heavier the object is, the greater the normal force. The greater the normal force, the more friction force there is. A special type of friction force is air resistance, also known as drag. This is the force of resistance to a motion that is created as an object moves and bumps into air particles. We often ignore air resistance in Physics 11 because it's difficult to estimate and has negligible effects on our problems in grade 11. The larger the surface area or smaller the mass, or the faster the object, the greater the effective air resistance. Air resistance is in the direction opposite to motion. The blue lines represent air particles bumping into the flat red object that is moving to the right. For free-falling objects, gravity will pull the object with a force Fg downwards. As the object falls, it will bump into air particles, creating air resistance, which would be in the opposite direction to Fg.